All right, oh, that's not clear, is it? There we go. I am looking at the option of either doing this one or this one here. I'm going to choose the division just because there's one more step, but really it's all basically the same thing. The first thing that we need to do is to factor all this mess. So this would be what? X plus 1, x minus 1. You should know that at this point. If you don't, do something to help yourself memorize. Like, it's so easy if you know it. Those are supposed to be really give me questions. And then I'm also flipping this. So I'm going to move this down to this bottom, x plus 1, x minus 1. And then this one up here, I'm going to have 3 factor out. I'm moving it to the top. I'm left with x plus 7. And then all of this mess, I'm going to have to factor that. Use our diamond. So we have, what, 21 and 22. So 21 and 1 is going to work. But I have to rewrite the middle term using these guys. So I have that. I take out an x, I'm left with 3x plus 1. I take out a 7, I'm left with 3x plus 1. So I have 3x plus 1. And the chain, the leftover part, becomes the other factor, x plus 7. So now I just do a mad dash of getting rid of things. So this and that goes away, and all of that goes away, and I'm left with 3 over 3x plus 1. Now, a lot of students have been asking me, can I reduce these since this is multiplication? The problem is this isn't multiplication. If it had been like 3 times x plus something, then yes, that whole thing could be gotten rid of that. But since this hasn't changed into a factored problem, you cannot get rid of those two things there. So you would leave that exactly like that. And a similar one ends up being on number 16, this one over here, is that you end up with something that looks like it can go away, but you can't cancel it because it's not factored. Okay?